Hi everyone. Today I'll be demonstrating how Elastic Security integrates with Microsoft Azure and how AI can enhance cloud security operations through automated alert analysis and attack discovery. At its core, Elastic's platform is designed for large-scale data search and analytics through their Elastic Stack. But over time, Elastic has evolved into a full SIEM and security analytics solution available as a SaaS product. It's capable of ingesting, integrating, and analyzing logs from both cloud and on-prem environments. In my setup, I've connected Azure Activity Logs, Event Logs, and Cloud Posture data to Elasticsearch, where Elastic Security continuously analyzes the data in real time. On top of that, I'm using their LLM-powered attack discovery feature, which automatically correlates alerts to uncover potential attack sequences. The built-in AI assistant can then explain those findings in plain language, for example, summarizing what looks suspicious or what steps might indicate an intrusion attempt. To set this up in Azure, I first created a managed identity with read access to my subscription. Then, within the Elastic Security portal, I configured my Elastic deployment to connect with my Azure environment. Next, I deployed the Elastic agent on a virtual machine within Azure. That's what enables full data collection. The platform provides pre-built scripts for these steps, which makes connecting Azure with Elastic pretty simple. Now, up until this point, I've just set up a traditional SIEM workflow, data ingestion, normalization, and basic analysis. But the real analysis starts when AI comes into play. Using the attack discovery feature, Elastic's model scans all alerts looking for related events that might indicate an attacker moving through multiple stages of an attack. You can see one of these potential attacks here, titled Azure Administrative Activities Sequence. When I expand it, the system shows that several administrative actions might represent initial access and execution commands on a virtual machine. Then, by clicking View in AI Assistant, I can chat directly with the LLM about what's going on. I can ask the LLM to further simplify the analysis or explain what parts of the log data is suspicious. In this case, the system detected that I had accessed Event Hub keys, connected to a virtual machine via the serial console, and executed commands. Now, I was just setting up log forwarding for Elastic, but the model identified that the sequence could look like an attack. So while this was a false positive, it demonstrates how the attack discovery tool is able to group events and detect patterns, exposing potential attacks. From a benefits perspective, this kind of automation saves a lot of time and effort. It allows security teams to handle massive volumes of alerts that could otherwise take hours or days to review. AI-driven analysis helps reduce response time, correlate events automatically, and can also translate technical logs into simple language, making incidents understandable even for non-technical stakeholders. Ultimately, it can enhance both efficiency and clarity. But of course, there are limitations. Broad pattern matching can lead to false positives, as I've just shown, and LLMs may sometimes misinterpret data or draw conclusions that don't fully align with reality. The AI's reasoning can also be somewhat opaque. It might tell you what it found, but cannot always explain the why in a fully transparent way. That's why human analysts are still vital for validation, context, and decision making. With that in mind, I believe AI and automation add the most value in pattern recognition, alert triage, and repetitive analysis, areas where speed and scale matter the most. But human judgment remains essential for interpreting context, validating alerts, and ensuring accurate responses. So, while AI can point us toward what looks important, it's still our job to figure out what's really going on.